This is the Ag Queen Podcast. This podcast explores the agriculture industry with the movers and shakers of those shaping it. Here's your host, Lori Boyer.
Today, I visit with Lars Dyrud. He is the Chief Executive Officer of a company called Earthoptics. We'll be finding out more about Earthoptics and what they do in the agriculture industry. Lars, let's start off by talking about you and your background.
Absolutely. Lori, thanks so much for having us on your show and taking the time to get to know us. I've been with the company since shortly after its founding. I joined first as a science advisor and then took over as CEO a few months later. So we've been around for almost 3 years now and have been working in bringing innovation to the whole soil mapping space. And so it's been just a ton of fun for me to get involved. It was a really unique opportunity. My career has been kind of split half and half. I'm a space scientist by training. So about half my career I spent designing satellite systems for Earth and space science, and the other half in technology, entrepreneurship, and startups. And so I'm originally from Minnesota. Both my parents grew up on farms on kind of the opposite end of the states. So I spent a lot of my summers on farms. And so I've been looking to try to get into agtech for quite some time, and had the good fortune I work in a lot of different technology aspects, many of which we're using here at Earthoptics today, whether it's using radar for sensing and other electromagnetic techniques, all the way to using machine learning to make map-derived data products. The last company I started specialized in machine learning information extraction from aerial and satellite imagery. And really, so a lot of the product techniques and methodologies that we develop with that are things that we learn and things that we can kind of reuse in some of our product capabilities here as well.
What led you into working with Earthoptics then, kind of the whole idea behind the company?
Yeah, I think there's myself together with the founders of the company. They shared the idea that there's just a significant innovation opportunity when it comes to soil measurement itself. There's been just incredible investment and progress that's been made in above ground agriculture innovation and technology over the last couple of decades. But it's really been mostly focused on plant science and in-season assessment. Things like using cameras for pest detection, incredible advancements. But what had been kind of left behind is measurements of the soil, the whole second half of the equation. So we just really felt there was a significant opportunity in bringing new technologies to bear that would allow us to map and measure soils and ultimately all attributes of soil, whether it's physical, chemical, even biological characteristics, to bring new measurement capabilities and allow us to both lower the cost, but dramatically increase both the resolution and kind of fidelity of soil measurement.
So a couple of the notes that I took here getting ready today, and you even mentioned them here during your introduction, is carbon mapping and soil mapping. So let me just start off with this. Give me the definition, if you will, of what soil mapping is.
That's a great question. And it's a term that we try to reuse all the time to make sure we're differentiating from traditional soil samples. So throughout most of soil measurement, we've been doing it about the same way for the last 75 years. You send somebody out to a field, they take a soil probe with them, they go pull some samples, put them in a bag, and send them off to a lab. And so really what that's telling you is whatever the lab's capable of measuring from the soil, but it's only telling you what's going on in the soil at those handful of points that you pull the soil sample from. And really, the soil is so incredibly variable, and the various properties of soil can vary so significantly from one location of the field to the next. That you really truly only know what's going on where you pull the sample. But since the act of pulling the sample and the cost of sending it to the lab are so significant, really people don't make as many measurements as they really probably want to or ought to maximize a long list of decisions that really depend on knowing what's happening where in different parts of the field. And so we wanted to bring the concept of soil mapping, the goal and the idea of wanting to know all soil attributes everywhere in the field, not just where you pulled the samples from. And that's what we're doing. So we achieve that by doing what other folks do, which is bringing satellite data and other mapping level capabilities. But we're also have been curating a set of sensors that we attach right now to side-by-sides and are working to get them attached ultimately to tractors and combines. So we're really being able to pull in information on every square inch of the field. We still take soil samples and soil probe measurements, but because of the sensor data and the other satellite data, we can take far fewer soil samples than we would have otherwise needed to. And through the technology and machine learning, we can extend the truth data that we measured from the soil sample to every square inch of the field through the sensor measurements themselves. It really is a new approach to getting information on across the entire field.
And you just said a term I want to explore just a little bit more. What is truth data exactly?
It's a machine learning term in many cases. And so the methodology we're using is we take soil samples or soil probe measurements that it's like anyone else ever has at a handful of locations in the field. And so the way we view it is, okay, at these exact locations, we know exactly whatever soil attribute you're interested in. So whether action or soil carbon concentration or bulk density or nitrogen levels, we feel at this particular location, we know exactly what the measurement is for that attribute. And what we want to know what that soil attribute is everywhere in the field. So then we also collect soil sensor data. So for us, that's ground penetrating radar and electromagnetic induction and elevation and other satellite data sets. And those are not measurements directly of nitrogen, carbon concentration, or bulk density, compaction directly, but they measure things that are related to that. So then we use machine learning and truth and training data to say, hey, here's what this, say carbon, for example. We know the carbon levels at say 12 locations in the field. We'll use that as truth and training data to create a model using machine learning that allows us to interpret our sensor data and other satellite data sets to turn them into essentially a carbon measurement. And so it allows us to kind of tease out the complex correlations that go into influencing things that GPR, EMI, and satellites do measure, which are not just one of those attributes, but really the combined effect of a lot of soil variability. So the truth and training data allows us to create a model to separate out the contribution of each of those individual effects.
Okay, thank you for that. Now, we'll probably come back to this because I know these tie in together, and I'm speaking about soil and carbon mapping. Let's talk about carbon mapping now. So it's the same type of definition as soil mapping then?
Absolutely. Yeah, so carbon's really exciting. We think it's a new, probably the most significant revenue opportunity and, sustainability opportunity for growers and everyone involved up and down the food value chain. We think it's probably the biggest thing that's happened for a while. And so there's big picture wise, a lot of scientists believe that modern agriculture practices have reduced global soil carbon stocks by somewhere in the neighborhood of about 120 billion tons over the last 50 to 60 years. And more carbon soil is good for everybody, and everybody mostly agrees that that's the case. So higher organic content improves soil moisture, improves uptake of nutrients, and so it's better for everything. And then so there's a goal and a significant interest from a growing members of the population that, hey, let's take efforts to get the soil carbon put back into the soil, and create even a financial incentive through things like carbon credits. And there's other programs that we and other folks are working on. But the truth is, it's a difficult measurement to make. In order for all those things to be successful, you got to be able to measure and in many cases prove that soil carbon levels are actually going up, they're increasing over time, whether it's through a change of practice or not. It's actually a pretty difficult measurement. So if you're trying to ask a really simple question, I've got a field here, let's say it's 100 acres. I want to know, is there more soil carbon in this field after a couple years of practice changes than there was 2 years ago or 5 years ago? And that's a hard thing to actually measure in principle. About an acre foot of soil weighs about 2,000 tons. And we, in general, are trying to pay folks about $25. Not by we, I mean the carbon credit and the carbon community. The marketplace is willing to pay growers, in many cases, around $25 per ton of soil, of new carbon that they put into the soil. And so that, when you think about and typically you can maybe add 1-2 tons of carbon per acre per year tops through various practice changes like cover cropping and reducing tillage. When you think about it, you're trying to measure 1 to 2 tons of change in carbon out of something that weighs 2,000 tons. That's a pretty small relative change, actually. And so it's a difficult measurement to make. What we have been working on and what we believe is the best way to actually make those measurements accurately are to do them every single year. Employ techniques like ours that map every square inch of the soil, but still use standard traditional probe measurements that you can truly rely upon and bring them together with as complex analytical capability as you can. That's the best way to actually measure directly. Even though they're small changes, we think they're measurable when you use the right techniques.
Beyond the farmer themselves using this data for precision agricultural purposes, who else uses the data? Who else uses it, and where else can it be used at?
Yeah, so ultimately, we're trying to collect soil information that all the stakeholders would want to use for their various decisions, the grower, of course, being the most important. So carbon concentration data can be used together with bulk density data, can be used to verify a carbon credit, for example, that's been issued. Carbon data, high resolution carbon data like we produce in our maps could be used to ultimately attach carbon values to food ingredients that come off the field to be associated for, say, marketing purposes. One of the things we say is, imagine going to the grocery store and being able to buy a box of cornflakes. And so the corn used to make these cornflakes took 1 pound of CO2 out of the atmosphere. That those type of marketing messaging could be enabled by these detailed carbon mapping and carbon measurements. So, and obviously, retailers and fertilizer companies want to know, current fertility levels to be able to make prescription recommendations on what to apply to the field in that year. So there's a long list of stakeholders that have some interest in knowing what's going on in the soil in a fairly detailed fashion. And different entities have different interests in different soil attributes, but we think it's a really great opportunity to be able to measure all the attributes of interest at really high quality, high detail, and provide that data to all the stakeholders who want access to it and need access to it to do their job.
And I'm curious, right now, would you say a majority of your clients are actual farmers, or are they entities or farmer representatives? Just kind of curious who is looking to use this current relevant data.
Always in the end, it's the grower and the farmers are the ultimate user of a bunch of the information we're making. The one modest difference to that is with carbon credits and the verification data we provide. Of course, that data is of interest to the growers, but it's usually a requirement in the carbon contract that they signed up to that verified. And so in general, the end user is the grower and the farmer, but almost always we are working through some other entity that's already working with the grower and providing this as an additional capability or service to either the agronomist or maybe equipment provider, manufacturer, or a carbon marketplace, for example.
So would you be considered a third-party verifier with regard to the carbon credit market?
Absolutely.
Okay. Where do you see Earthoptics going here? I guess maybe both in terms of near future and a little bit further out, with so many discussions in a political arena and, of course, just new technology coming on board all the time.
Yeah, really, our vision and goal is to be the Google Maps of soil measurement and mapping. And so we want to provide a service that's so ubiquitous and comprehensive that none of the stakeholders, including the grower I just described, would have a need to go out to the field to pull samples anymore. That all the soil data information they need is going to be accurate, up to date, and relevant, and available from us. And we think that'll drive a lot of efficiencies for various stakeholders around farming. And carbon is, of course, one of those key soil attributes. And so obviously, a lot of folks are really excited about the promise of these new carbon marketplaces and other carbon programs. And so it's a big driver for some of our growth. But ultimately, we see carbon as a really important soil attribute among many that we're working to deliver to everybody on hopefully a ubiquitous basis.
Okay, just a couple more questions for you here. A lot of farmers and a lot of entities, I guess, if you will, are really starting to use apps to put their information in to find out more information, like similar to what you're talking about on where they can save from putting fertilizer, or where they should be put more fertilizer in that precision ag realm. Is the data that you supply to your clients easily used in an app? Can it work with apps? Can they talk to each other? Does that make sense?
Yeah, absolutely. And so that's consistent with our entire approach. So everything we do is cloud-based. Growers own all the data that we generate for them, but we can make it accessible, of course, with their permission to the other service providers they're using via API through the cloud. And that really is our goal. Much like, if you use your phone or another device, and a business might have a Google Map integrated with their suite. They didn't make the map, but they integrated another service into it. And that's how we see ourselves. So we want to be the key data providers of all things soil and have our data as easily integratable with all the other services that growers are getting. Our goal is to not provide recommendations, but to provide the data that everyone can use to build their recommendations and make their decisions off of.
And just one thing I should have asked you earlier, you're based out of Raleigh, North Carolina, is that right?
Yes, we actually have this kind of spread out throughout the country. We've got an office in Arlington, Virginia, a small facility in Blacksburg, Virginia on the Virginia Tech campus. Raleigh, North Carolina is where we started off. And then we've got a facility in Mankato, Minnesota, and Northwest Arkansas.
Okay.
Where a lot of our field services are originated out of.
Anything else you want to mention that I didn't ask about?
No, I think you've done a great job hitting on a lot of the high points. And so I really appreciate you taking the time.
I thank my guest, Lars Dyrud, for joining me here today, the Chief Executive Officer of Earthoptics. For more information, log on to earthoptics.com.
Thanks for tuning in to this edition of the Ag Queen Podcast with your host, Lori Boyer.